which is classes. Okay, so today's lesson is like it's a part 2 of what we covered last week, which is classes. Today we're going to talk a little bit more about classes and some of the concepts that we didn't cover. All right, so we're going to talk about what public and private mean. That's a pretty short lesson. And then we're going to talk about scope, the scope of variables and the scope of methods. So without further ado, let's get right into it. All right, so public and private. So remember how we always, whenever you guys created instance variables, we always wanted you guys to make it private? Well, we'll tell you why in this lesson. All right, so first of all, public variables are variables that can be seen by everything, even by other files in the same folders. So every program is a file. And let's say I had 2 programs, all right? I had a program called A and a program called B. If I created a public variable inside of A, then objects inside of B can see those public variables created inside of A as long as they are public. So if you have public variables, then there's a lot of things that can access them, which obviously might be good and can also be bad. And then as for private variables, it can only be seen by the class that it is inside of. So it's very restricted. It's the opposite of public. And private variables are mainly used when you don't want another class to directly access it. And an interesting thing about private variables is that, let's say I created a private instance variable, which is what we want you guys to do. But then we create an object of the class where those private instance variables are located in. Well, since the variables are private, objects can't actually access those instance variables if the instance variables are private. And if you want to use these, we have to use get and set methods, which we'll talk about a little bit later. All right, so a little bit more on public and private. So just like with variables, you can use public and private with methods or function, static method, instance method, whatever. And the same rules apply. And this is important. You cannot make a private constructor. So the only thing that a constructor has is that it's public, and then you have its name, and then parameters, which are optional. There's no return type, and it can't be private. All right, so, and pretty simple, but private variables are implemented by replacing the public with private, or if you didn't have public in the first place, you just add private. So here's a little example. You create an integer variable called sum, set it equal to 5. And this is what we're normally used to seeing. And I don't think we don't go over this in today's lesson, but if you don't have private and you don't have public, then the default is just protected, which is another access modifier. But public and private are the 2 main ones. So if we create this variable and the access modifier is private, then if you want to use this variable sum, if something wants to use the variable sum, it has to be in the same class where sum was created because it's private. So that was a little bit on public and private. Oh wait, there's one more. All right, and the AP test, AP Computer Science test, requires that you put all of your instance variables as private unless the problem otherwise specifies. And in addition to this main requirement for the AP test, putting instance variables as private is also just best practices and would help you prevent some naming conventions, right? Another advantage of creating private instance variables or variables in general is that other programs and classes cannot easily change the contents of the variable without any checks. And these checks are going to end up being get and set methods, actually mainly set methods. But yeah, so now that was public and private, short and sweet. Does anybody have any questions on that? Just wait 5 seconds. 1, 2, 3, 4, 5. All right, now the next part of this lesson is on scope. And everything, especially variables, have a certain scope that is assigned to them, whether you put public or private in front of it, or if you don't, right? And the default scope of a variable, if you don't make it private or if you don't make it public, is protected. And protected means that you can only use that variable from its creation to the next curly bracket, not bracket in general, just curly braces or bracket following it. And if you use scope properly, or if you use it the correct way, you can actually have multiple variables that have the exact same name, as long as the scopes do not overlap. So an example of the second bullet point is, let's say we have a for loop. And usually when we create a for loop, we create a counter variable, right? It's for int I equals 0, semicolon I, the condition, and then the increment. But when you say int I equals 0, that is a variable, and its scope, since it was created inside of the for loop, its scope is also inside of the for loop. So anything inside of the for loop can access int I, but anything outside of the for loop cannot access int I. All right, so what if we wanted to have two for loops, all right? And two for loops, both of their counter variables are integers, and both of them have the same name, which is I. Well, that would actually work because the scopes do not overlap. You see, the first I variable can only be seen in the first for loop, not by the second for loop, and then vice versa for the second for loop. But so that's why, all right, so if the scope does overlap, though, it becomes confusing as to which variable you are referring to, right? If you have two variables called A and you want to say print A out, then Joe doesn't know if you're using this A or the other A. And even though in the previous example I showed how you can actually have variables with the same name, it's best practices to try and avoid that, because it might confuse someone who's reading your code, or might even confuse yourself, maybe. And private and public are ways to revise the scope of variables as well as the scope of methods. All right. So let's go over some examples. So take a look at this piece of code. Will it run? Like, will it give you no error? Should we give them some time to look over it, or should I just directly say the answer?
No, give them some time to look over it.
All right, we'll just give you guys 1 minute, I guess.
So give a true if you think this code will run, give a false if you think it will not run. And by running it, means like, okay, I see a true. Another true.
Oh no.
Don't give them any answers yet. Okay.
All right, so I think most people said true. Yeah, it doesn't really have to do with scope, but unfortunately, this actually will not run. The reason why it won't run is that, look here, we have int I equals 5, but then we have another variable called I. It's also an integer, and we're creating it inside of the for loop. And since when you create a variable, the variable has a certain name, right? You can't create another variable with the exact same name unless, actually, well, you just can't create a variable with another variable with the exact same name unless it's in a different scope, or the scopes don't overlap. But in this case, int I equals 5, since it is outside of the for loop, what's inside of the for loop can access int I equals 5. But since you recreate I equals 0, then the program wouldn't work, because you create the same variable twice, you see, but the scopes are overlapping. So that's why this code wouldn't work. And if you wanted it to work, then you just have to switch it. We have to remove the int. We don't make it a declaration. We just simply change the value to I equals 0. So see the difference? The only difference is that we chopped off this int to make it work.
Okay, sorry, just to cut in a bit. So just to specify. So Leo, could you go back to the previous slide? So for this one, the scope of the int I equals 5 variable is the whole program right now, because like it's declared outside, and in reality, it would be within the main method. And so the scope would be the whole main method. But for int I equals 0 one, that particular variable only has a scope of the beginning of the curly brackets of the for loop to the end of the for loop. So, but the thing is, because int I equals 5, that variable can cover the whole program, and which also includes the for loop as well. That's the reason why it does not work. And Leo kind of already like explained this already, but I just wanted to like make it clear. That's kind of the reason why like the scopes are overlapping, so therefore you cannot do that.
Did everybody get that? All right, well, I hope everybody gets that, but here's a few more examples. So, will this code run? Say T, yes, it will run, or false, no, it will not run. Should we go over now, or should we a little bit longer?
Give it a little bit longer. So think about the scope in this case. Okay, I see it true. Think about the scope, right? So when we're creating a variable within a for loop, what is the scope of that particular variable? So like, is it the whole program or is it just within the for loop? All right, anybody else have an answer? I only see one so far.
Kevin gave me his answer.
Okay. Okay, let's go over them, I think.
All right, so the correct answer would be false. And the reason why is that int I equals 0, the scope of the variable I is between the two curly braces where it was created. So that means it would only be seen by stuff inside of the for loop. So this code would work, but once you exit outside of the for loop, then anything outside of the for loop is not within the variable i's scope anymore. So this code, system.out.println I, wouldn't work since it's outside of the for loop, and thus outside of the scope of the variable I. So this means this will not work. And let's do another example. This one's a little bit more, it's a bit longer, but see if you guys can get it. As usual, put T if you think it's going to run, and then F if it's not going to run.
And again, think about what we define scope as. So scope is from where the variable was created to the next curly bracket reaches, the next end of curly bracket. So think about that when kind of looking over the code. And since this is a static method example, we can probably wait a bit longer. Any guesses so far? All right.
Kevin said true.
There's a true. Anybody else have a guess? All right, just take a guess. It's fine if you're not sure, but take a guess. What do you think? Okay, I see another true.
All right, should we go over it? Oh, wait, whoops.
Yeah,
Okay, well, I can't.
it's
Yeah, I
fine.
didn't mean to put there, but. All right, I'm not sure. I
You want
answered
me
your
to explain it?
question. Sure. Oh, okay. All right, so look at here. All right. So we create input. Okay, sorry. We create a string variable called input, and we set it to hello. But now, as you can see down here, we're going to create a public static method that returns a string. And say was example. All right. And it's going to take in a string parameter called mystery. So whatever we pass in when we declare the function mystery, so we're going to be using here, return mystery dot hi. And okay, I'm just going to click that so it doesn't work. Okay. String input equals hello, print ln, example input. So wait, actually, wait, can you explain it?
Yeah, I can. So, okay, so like Leah is saying, we create a string input and we set it to hello. And then you can
Oh,
see
wait, never mind.
the
Okay, I
second
see.
line that we're putting the input variable, so hello, into example. So what happens then is because we go down to the static method then, and we're saying example, and then we're taking in the parameter string that we got, which would be hello in this case. And so we're going to return hello plus hi, right? Because that's what the mystery plus hi is doing. So we return a hello hi, and that just prints it out to terminal. But the thing is, the next line in the main method, we're saying system.println mystery. But the thing is, the string mystery parameter, that only exists within the static method, right? Because it's only taken in when it was first created in the parameter, right? But it only exists to the end of the static method because that's the next end curly bracket. And so because of that, you cannot call that same parameter in the main method because it doesn't exist there. That's not the scope of the mystery parameter. And therefore, that's the reason why you can't actually call it. And that's why it'll give you an error. Okay, let's pause for a second. Scale of 1 to 10, how are you guys feeling? Does this sort of make sense? All right, thank you, Kevin. Anybody else? I know this, like, everything's like, whoa, at you, but give us a number. All right, thank you, Jesse.
All right, should we keep going then?
Yeah.
All right. So we've been throwing around the terms instance and static, instance variables, instance methods, static methods, static variables. What's the difference between the two? All right. So static methods are associated with a class, but not an object. And this means that if you want to use a static method, then you don't have to create an object if you want to use it. All right. And then instance methods are the actions of an object, which means they're also associated with that object. And that also means that if you have an instance method inside of a class, then since the instance method is part of an object and not the class, you have to create an object of the class that contains the instance variables, and then you have to use the object dot, or whatever the object name is, dot, and then the instance method name. So that's the difference. Static method associated with the class, need to use the class to call it. Instance variables associated with an object need an object to call it. All right. And similarly, with static and instance variables, static variables are the static variables are the properties of a class, while the instance variables are the properties of an object. All right, so let's say we have a class called example, and I have a static method inside of it. All right, let's say the static method was just called execute. Then to use a static method, I would just have to put the class name, which is example, and then a period or a dot, and then I would put the static method name, which is execute. All right, so see how we're using a class dot the static method name, but for the object, you first have to create an object of the class. So example, I don't know, example object equals new example, and then a semicolon, and then we have to use the object's name, which is what's the object's name again? All right, I don't know, object, and then to put a period, and then the instance method name. So that's the difference and an example of how to use them. And yeah, so static variables and methods don't need to have a construction of an object to be used, while instance variables and methods do. And you can just call static variables and methods directly without creating any objects or anything like that. But static methods are called using a class and then method name rather than by object. All right, so quickly to memorize this. Static is associated with the class. Instance variables are associated with objects. All right, so here's a few notes. So for example, let's say we had a public class named A, and we had a method inside of that class, and its name was X. All right, and let's turn out that this was a static method. And to call a static method, we just put the class name, in this case it would be A, the dot or period, and then the static method name. In this case, it would be X, and then we have parentheses and the semicolon. This is how you would call the method X. And note, this is another way to call static method besides just writing out its name and the parameters, but only if you're calling this method inside of the class. All right, and if this was, let's pretend this was an instance method, then you have to create an object of this class, and then you have to do the same thing. It would still be .x, but instead of calling the X method on A, you would call it on the object name, not the class name. So here's for notes. And let's say you were calling a method from a separate public class that is not located inside of the public class, or you're calling it, then this is where this method, this type of calling would have to be used instead of just directly calling the method. So just instead of using just X parentheses, if it's in a separate class, you have to use A.X parentheses and then semicolon. And also note that you can have static methods in classes as well. So then when you call them, you would just use this method of calling class name dot static method name. And here's an example. So okay, here. All right, so don't worry about this code thing, but let's just go here. So since we have a public class and we have it called A, and they have a separate static method called X, and it's going to pass in integer variable called temp. Well, since the static method is located inside of the class, if you want to call this static method, and all you have to put in the main method would just be X. Right, so you would just have to do this. All right, you just put the class name dot the static method name, whatever parameters it has. In this case, it would be the integer, and then that's how you would call a static method. But if it was an instance method, we have to do something like this. let's pretend this is a separate class. Actually, all right, so this is how you do it for static methods. And then, wait, actually, can I just, all right. Anything? Okay. All right, and then for the second example, let's pretend that we now have a second class. We have two classes. We have a class called A, and we have a class called B. Inside of class B, we have an instance method, all right, not a static method. And then we want to call, actually, we have to call the method call inside of the method right here. So since it is not a static method, you can't just use the type of method where you just say, wait, hold on. So if call, this method was a static method, then all you would have to do inside of public class A is b dot the method name, which is call, and then a parameter, which is 5. But since it is not a static method, then you first need to create an object of B class, which we do here.
Sorry, just a quick note. I think when I was partitioning this, I partitioned it wrong. So the actual class B that goes with the number 2 problem is actually below public class A. So scroll down.
Oh,
Yeah, sorry, I partitioned it wrong. That's physically there.
okay. Well, isn't it the same code though?
No, it's not.
No, it's a little bit different. All right. Okay. Real quick. All right. Okay. So in public class B, or it's not a public class, in class B, we want to use the X method. That's also a we want to access the static method X inside of a separate class, which is called class A. So to do that, since it is a static method, you will just use the class name reference instead of the object name reference. So you would put the class name where the method is located. So it would be A, and then you would put the static method name, which is X, and then you would pass in a parameter, and that can be, whatever. And the reason why we're allowed to use the class and then the name is because it is a static method, not an instance method. All right. However, let's say here, all right, dot call. As you can see, the call method is not inside of the class where you want to call the call method. It is in the class B, not the class A, which means that it is an instance method. And to use an instance method, then you have to create an object of the class where the instance method is located in. So here we just have the class name. We have the name of the object you want to create, which is in this case the example. We use the new keyword, and then we use the class name and then parameters. And since the class B does not have a constructor, we don't need to pass any parameters between these two brackets. All right, so now that we have our little object of the B class, then we just use the object's name dot the name of the instance method, and then whatever parameters that it requires. Does everybody understand how that works? Okay.
All right.
We've got one through.
Sorry, I think